Hello, friends. I'm thankful to the GMERS at Rajpipla who gave me an opportunity to speak to the first year students of MBBS. The students gave a very good response because the topic was AI and ML for the beginners. Artificial intelligence and machine learning is much in vogue today, and that is the reason why the entire summary of the session is presented here as a dialogue between two AI avatars. AI tools have been used to produce this. Please go ahead and listen to it and have fun. Thank you.
Welcome back to the deep dive. Today, we're tackling something everyone's talking about, but maybe not always fully grasping. We all know the names, right? ChatGPT, Gemini, Copilot, they're everywhere. But what's the real connection between artificial intelligence, AI, and machine learning, ML? We want to get past the buzzwords.
Yeah, look beyond the headlines. So our source material for this deep dive, it's from an advanced training session, actually, designed for, well, technically savvy professionals, people like you looking for real clarity on integrating AML into what they actually do. We're not just scratching the surface today. We want to understand the mechanics. How does it work? And crucially, why should you care? How does it apply?
That's absolutely the goal. Our mission today is pre-focused. First, let's quickly unpack how these machines actually, learn. That's the key to using them well. And then let's pinpoint where this tech is making a real immediate difference right now, high stakes areas. But also, let's be clear about the essential role humans still play. Human intelligence isn't going anywhere. Right. And to make these complex ideas feel a bit more grounded, we'll be using some helpful analogies. Things like how Netflix figures out what you want to watch next, or even how a toddler learns to sort shapes. Simple ideas for complex tech.
Okay, let's start with that core relationship, AI and ML. When you hear those terms, think of it like this. Machine learning, ML, that's the foundation. It's the toolbox, the methods. It's what allows artificial intelligence, the AI part, to actually achieve its goals. You really can't have functioning AI without ML doing the heavy lifting underneath.
And comparing it to how we learn seems like a really useful way in. I mean, think about your own life. You build up knowledge, right? From family, school, work, all that training, that experience. It gives you the ability to make decisions when something new comes along. The source material suggests machines kind of follow a similar path, learning from data.
It's surprisingly good analogy, actually. They are trained on vast amounts of data, and from that they learn to make predictions or decisions. Not conscious decisions like us, of course, but based on the patterns they've identified.
So, that experience we all have online, when a platform seems to know exactly what we're looking for, Netflix suggesting the perfect show, or Amazon saying people who bought this also liked, that's ML in action.
Precisely, that personalization, that's the output. But let's peek behind the curtain. What's happening on the back end isn't some kind of magic. It's very sophisticated, very fast. Pattern matching. Take that online shopping example. If you keep searching for, say, a very specific blue kurta, maybe with a certain neck design,
Hmm.
the machine notes that. But it's not just the item. It's learning the pattern, your style preference, maybe your price range, even the time of day you shop. It builds a profile, a buyer persona, all based on recognizing that pattern in your behavior.
And I love the simplicity of connecting this to childhood learning, that toddlers shape sort of toy. Square block, square hole, circle block, circle hole. The machine making that recommendation, suggesting the next item, is basically just matching the input, like your search for the kurta, to the shape of pattern it's already learned about you. That is ML stripped down.
Exactly. It's fundamentally about recognizing and acting on established patterns.
Okay, so let's talk about those big names again. ChatGPT, Grok, Gemini, Copilot. The source compared them to different brands of toothpaste. Is that fair? Like they all basically do the same thing.
It's a useful starting point, yes. They often share a core technology, typically a large language model or LLM, but like toothpaste, the flavor and packaging differ. For a technically savvy user, you listening right now, the differences in how they're trained, the specific data they use, their scale, those proprietary details do actually matter quite a bit for performance in specific tasks. But understanding the core function is key first.
So focusing on function, the Copilot idea came up strongly.
Yes, and this is a crucial framework. Think of these tools as assistants. They fly alongside you. You, the human, are always the pilot in command. They're a resource, an enhancer, not a replacement for your judgment.
Okay, that makes sense. An assistant.
But assistants need training, right? And this is maybe the most critical point. The effectiveness of your AI copilot depends heavily on the time and effort you put into training it, the context you provide. One speaker in our source material talked about using their copilot for, get this, over 18 months, systematically training it, giving it context across different jobs. They held growth officer, strategy lead, CEO, even academic work.
Wow, 18 months.
Yeah, that investment means the tool can now instantly recall relevant presentations or context from months ago when they ask it something new. It understands their world.
Hold on, though. Does that mean everyone needs to spend a year and a half training their tool just to make it useful? That sounds like a huge barrier for most people.
Good question. It raises the point about expectations. I don't think the speaker meant it takes 18 months just to get started. You can get value much sooner. The point was about achieving that deep, personalized, multi-context understanding. Making it a truly high-functioning assistant tailored to your complex professional life takes ongoing effort.
Okay, so the practical takeaway isn't wait 18 months. It's start training it now, consistently, in your specific area.
Exactly. If you're in, say, medical device regulation, you need to feed it relevant regulations, discuss case studies with it, define your specific focus. It's an active partnership. You provide the specialized input. It learns to assist within that context. It's not plug and play for deep work.
Right. Which means we probably need to get slightly more technical about how this training actually works. The source mentioned algorithms, models, and training. Let's unpack model. What is an AI model?
Okay, think of a model as a specialized structure. It's like choosing a field of study. You start broad, maybe science, then you narrow down to medicine, then you specialize even further, like cardiology. An AI model is specialized like that. It's a complex mathematical framework trained for a specific purpose. So large language models, LLMs, the ones powering tools like ChatGPT, are specialized in understanding and generating human language.
And how are they specialized in language?
They're based on something called natural language processing, or NLP. This is crucial. NLP techniques allow the model to learn the patterns, the grammar, the context, the relationships between words in vast amounts of text. That's how they can generate coherent sentences, paragraphs, even articles, like our Kurta example, but for language patterns.
Okay. And the training itself, the source mentioned two main types, supervised and unsupervised learning. Can you break those down? The original analogy was a bit basic.
Sure. The key difference is the kind of data used. In supervised learning, the model is trained on labeled data. Think of it like flashcards to the AI. The human trainer provides the input and tells the machine the correct output or label, like showing it a picture and saying, this is a dog. The machine is supervised because it's explicitly told the right answer, the correct pattern match.
Got it. So one's from examples with known answers. What about unsupervised?
Unsupervised learning is different. Here, the model gets unlabeled data, just a massive amount of information with no predefined answers. Its task is to find patterns, structures, or clusters on its own. So it might figure out, without being told, that people who search for blue kurtas also often look at specific types of shoes just by analyzing purchasing habits. It discovers the patterns independently.
Okay, so one learns from labeled examples, the other finds hidden patterns. But this reliance on data, it leads directly to some risks, right? The source highlighted bias and hallucination.
Absolutely critical risks. Let's take bias first. This creeps in when the training data itself is flawed. If the data is incorrect, incomplete, or reflects existing societal biases, maybe underrepresenting certain groups, the AI will learn those biases because it learns for the data we give it. So biased input leads to biased output, resulting in decisions that might be unfair or just plain wrong.
In hallucination, that sounds dramatic.
It is. And the source used the medical term deliberately. Hallucination in AI refers to the model generating output that sounds plausible, confident even, but is actually completely false or nonsensical. It happens when the model gets confused, maybe due to conflicting information in its training data or contradictory instructions in the prompt. It tries to reconcile the conflict and ends up essentially making things up.
Wow, so it's not just about wrong answers, it's about confidently presented falsehoods.
Exactly. And it's a powerful reminder. AI is created by humans, trained on human-generated data or data reflecting human actions. It inherits our limitations, our biases, our knowledge gaps, flawed input, potentially flawed output, garbage in, garbage out, as they say.
So given these risks, bias, hallucination, reliance on imperfect human input, how are major fields, especially high-stakes ones like medicine, dealing with this? And this whole idea of disruption AI brings.
Yeah, disruption is a loaded word. People often hear it and think job losses or chaos. But really, disruption just means a significant shift in how things are normally done, a change to the standard procedure.
The source used the COVID-19 pandemic as an example, a massive, unexpected disruption.
Right. And it forced change, didn't it? Suddenly, people had to adapt. Okay, maybe learning to make coffee was trivial. But professionally, think about the rapid shift to remote work, the adoption of tools like Zoom, even by older generations, new ways of delivering services.
It forced agility.
That's the key word, agility, flexibility. Disruption itself isn't inherently good or bad, it's an accelerator. Your ability to be agile determines whether you convert that acceleration into an advantage or get left behind. And that mindset is crucial in fields like medicine facing rapid AI integration.
Okay, so focusing specifically on medicine, where is AI adoption actually happening the fastest, according to the sources? It wasn't everywhere equally.
No, it wasn't. The clear leaders identified were radiology, pathology, and oncology.
Why the specific areas?
It comes back to the data and pattern matching. Think about it. What do those fields rely heavily on? Images, digital images, X-rays, MRIs, CT scans, digitized pathology slides. They have vast amounts of relatively standardized, high-quality digital data. That makes it much easier to train accurate AI models, especially using supervised learning, compared to, say, the unstructured, subjective notes a primary care doctor might take. The data is just more machine-readable.
Right, the data format makes a huge difference. But, okay, if the AI gets really good at reading those scans, finding the patterns, where does the human doctor fit? And the big question, if the AI assists with the diagnosis and gets it wrong, who's responsible?
The ethical line here, according to the source, is crystal clear. The responsibility always rests with the human professional, the doctor, the radiologist. You are the owner of the final decision. The AI is a tool, a co-pilot. You can use its analysis, you can ignore it, but ultimately, your expertise, your judgment, your name is on the line.
So the human remains the final checkpoint.
Absolutely. And we need to emphasize what humans bring that AI currently doesn't and perhaps never fully will. First, understanding gray. Computers think in binary, 0 or 1, black or white, correct or incorrect based on the patterns they know. Humans, we live in the gray areas. We understand nuance, ambiguity, context, exceptions to the rule. That's crucial in complex fields like medicine.
And the second thing?
Emotions, empathy, connection. Humans provide that emotional support, the reassurance, the ability to connect with a patient on a human level. That trust, that empathy is a massive part of healing, and it's something an algorithm simply cannot replicate.
That human touch remains vital.
Essential.
Okay, this connects to a really interesting concern raised in the source material. A student asked, if we use AI to simplify things like summarizing a long chapter quickly, does that make our brains, well, lazy? Yeah. Do we lose our ability to think deeply?
It's a valid question to ask, but the source suggested reframing it. Think about efficiency, not laziness. The analogy used was an electric toothbrush.
Okay, how does that connect?
Well, an electric toothbrush cleans your teeth much more efficiently than a manual one, right? It does the heavy lifting of the brushing motion better and faster. Does using one make your commitment to dental hygiene weaker? No, it arguably makes it easier and more effective.
Ah, I see. So the tool improves the process, potentially freeing you up.
Precisely. The AI summarizing the chapter is like the electric toothbrush. It handles a routine task efficiently. The key is what you do with the time and mental energy you save.
So it's about reinvesting that saved time.
Exactly. If the AI handles the initial data sift or summary, you should use that time for higher-level thinking. Critical analysis of the summary, questioning its assumptions, applying the information to complex, non-standard problems, focusing on those gray areas the machine struggles with. It's about leveraging efficiency for deeper work, not avoiding work altogether.
Makes sense. Use the efficiency gain wisely.
Right, so let's try to tie this all together. What we've unpacked is that AML is essentially a very powerful pattern-matching co-pilot. It needs careful, diligent training with good data. And it needs constant human oversight and feedback to keep it on track and mitigate those risks of bias and hallucination.
And for you, the professional using these tools, it comes down to balancing power and responsibility. AI offers incredible power speed, efficiency, new insights, but with that power comes a greater responsibility to use it ethically, to understand its limitations, and to always apply your human judgment. You're still the pilot.
Which leads us to that final thought, that provocative question from the source material for you to really consider.
Yeah.
If AI gets better and better at handling the pattern matching, the data review, the rapid initial analysis in your field, what's left? What are the truly complex questions, the uniquely human challenges that only you, the professional, will be equipped to tackle? And more importantly, how are you going to start training yourself now to excel in that critical gray area, the space between the AI's black and white, because that's where the future of human expertise truly lies?